Alkenes are hugely important industrial feedstocks, and their importance, especially in petrochemical industry, lies in the fact that they have a functional group, and so they can be transformed into a whole range of value-added chemicals, unlike alkanes, which are most voluminously used as fuels. So the simplest alkene, ethylene, can be transformed into a whole range of other products. It can be hydrated to give ethanol, which is an important component of chemical industry in its own right. It can be converted into vinyl chloride, which is a precursor to polymer PVC, polyvinyl chloride. It can be converted to acetaldehyde, shown here, which can then be taken on to acetic acid, which is used in human nutrition as well as a really important feedstock. Ethylene itself can be polymerized to give polyethylene, which is used to make plastic bags and a whole range of other things. And it can also be converted into this three-membered ring, the ethylene oxide, which can then be hydrated to give this molecule known as ethylene glycol, which is a component of antifreeze. So this very brief picture, which is far from being complete, shows how many hugely important chemicals are all derived from ethylene. And so you can easily see that this is a huge industry. Propylene, ethylene is also the alkene that is used by far the most by volume, but it's certainly not the only one. So propylene is also useful in a number of applications. It can be polymerized into polypropylene. It can be converted into isopropyl alcohol, which can then be converted into acetone, also a hugely important chemical. Again, just like ethylene, it can be converted into this three-membered compound, propylene oxide, which then can be taken into propylene glycol. And so, as you've seen already in these two examples, alkenes are routinely polymerized, and many small alkenes are subject to this process to get to very valuable chemicals. And so if we look at propylene, polymerization of propylene, which can be induced by a number of methods, gives us a molecule which has this repeating unit, which goes really to infinity, which contains simply of subunits of former propylene molecules. So this will be CH3 group here, each CH2 and any alternate carbon. And so this will be the polypropylene structure. These polymers are known to be formed by so-called addition polymerization, where each monomer adds on to the other one. And this will make much more sense next time when we talk about reactions of alkenes and introduce addition. But this, for example, would be an example. It would be a structure of polyvinyl chloride, also known as PVC. Again, as I said, the polyethylene, polystyrene, Teflon, they're all basically alkenes which are polymerized through these addition polymerizations. So from just this very brief overview, you can see that alkenes are really one of the cornerstones of chemical industry. In addition to this, they also exist in a number of pharmaceuticals, one number of pharmaceutical natural products, and many other things that we use on a daily basis. Unsaturated fats, for example, you hear a lot of talk about them in nutrition, are called unsaturated because they have alkene group. So this is really one of the omnipresent motifs in nature, and we will see in subsequent chapters how some of these chemicals that are derived from alkenes, first of all, how these reactions work, and what are these chemicals themselves used for. In the next subtopic, we will see a little bit about how do we evaluate stability of different alkenes and how do these stabilities really compare to each other.